About 717 million years ago, a mysterious phenomenon spurred runaway glaciation from pole to pole, plunging our planet into a state now known as snowball Earth. Around the same time, the area from present-day Alaska to Greenland was struck by catastrophic volcanic activity. Now, a new study suggests that years of continual eruptions were to blame for the snowball effect, dumping massive amounts of aerosols into the atmosphere and rapidly cooling the planet. Researchers from Harvard University suggest that the occurrence of both the snowball Earth and major volcanism is no coincidence. We know that volcanic activity can have a major effect on the environment, so the big question was, how are these two events related? Said Frances McDonald, the John L. Loeb Associate Professor of the Natural Sciences. The team first thought interactions between basaltic rock and carbon dioxide in the atmosphere could be to blame, but this process would take far too long. Instead, they looked into aerosols as the possible cause and found that under the right conditions, these volcanic emissions could give rise to such dramatic effects. It is not unique to have large volcanic provinces erupting, said Robin Wordsworth, Assistant Professor of Environmental Science and Engineering at the Harvard John A. Paulson School of Engineering and Applied Science. These types of eruptions have happened over and over again throughout geological time, but they're not always associated with cooling events. So, the question is, what made this event different? In this region, known as the Franklin Large Igneous Province, volcanic rocks erupted through sulfur-rich sediments. These sediments would then have been launched into the atmosphere as sulfur dioxide, a compound known to block solar radiation in the upper atmosphere. This was seen during the 1991 eruption of Mount Pinatubo in the Philippines, which dumped 10 million metric tons of sulfur in the air and reduced global temperatures about 1 degree Fahrenheit for a year. It is most effective when it passes the tropopause, where it's less likely to be brought back down to Earth through precipitation. There, it can linger in the atmosphere for a year. In periods of Earth history when it was very warm, volcanic cooling would not have been very important because the Earth would have been shielded by this warm, high tropopause, said Wordsworth. In cooler conditions, Earth becomes uniquely vulnerable to having these kinds of volcanic perturbations to climate. What our models have shown is that context and background really matters, said McDonald. They also found that where sulfur dioxide reaches the stratosphere is critical in the effect. About 717 million years ago, the Franklin Large Igneous Province was near the equator as a result of continental drift. This is where most of the solar radiation that keeps Earth warm enters, meaning the light reflecting gas entered at just the right spot to spur cooling. On top of this stretch of volcanoes created the perfect storm scenario. These volcanoes spanned an area roughly 2,000 miles across Canada and Greenland, and were able to erupt continuously, like those now seen in Hawaii and Iceland. If this were to go on for a decade or so, the volcanoes may have added enough aerosols into the atmosphere to destabilize the climate. Cooling from aerosols doesn't have to freeze the whole planet. It just have to drive the ice to a critical latitude, said McDonald. Then the ice does the rest. As ice increased, the surface reflected more sunlight, causing the planet to cool even further. And eventually, once the ice hit a latitude at about where California now sits, it caused a runaway snowball effect. It's easy to think of climate as this immense system that is very difficult to change, and in many ways that's true, said Wordsworth. But there have been very dramatic changes in the past, and there's every possibility that as sudden of a change could happen in the future as well. The researchers say understanding these events could provide important insight on past extinctions and even help us predict how proposed geoengineering tactics may affect climate change. This research shows that we need to get away from a simple paradigm of exoplanets, just thinking about stable equilibrium conditions and habitable zones, said Wordsworth. We know that Earth is a dynamic and active place that has had sharp transitions. There is every reason to believe that rapid climate transitions of this type are the norm on planets, rather than the exception.